All right, so the threshold frequency, like I was saying before, is just the lowest frequency of light that will cause the metal to emit electrons. Those would be just the electrons right at the very top of the surface of the metal. The valence electrons that are close to the surface require the least amount of energy to get out. But there is an energy to get out. Like red light at the top there may not get them out, but maybe a green light will be able to pop them out because there's still amount of energy to pop them out of those electrons or those atoms there. The deeper they are, they'll require a little bit more energy to get up. Remember, it's one photon to get out. So even if I can pop one out up here, one down here with the same photon won't be able to pop out because there's too big of a change or too big of an energy gap here. So it'd require a little bit more higher frequency, higher energy to pop them out, but one photon for every electron. So most of the time when we talk about these electrons, we just talk about the ones right at the very surface, right at the threshold. So we talk about the maximum kinetic energy that when it comes out because it used the least amount of energy to dig himself out. Okay. So we can relate that as well. We can relate the energy that's required to get out to the frequency, that threshold frequency, because Planck says that the frequency of light can be changed into energy because they are just packets of energy, according to Planck's and Einstein and Gilbert Lewis and stuff. So we can change this into what we call the work function. So there's another W for some reason is equal to H times F. So this W is the work function, is the energy of the photon that is required. So it's like a threshold again to get an electron from the metal. It's the minimum amount of energy. I'm going to just mention that. The minimum energy of the photons of light that is required to remove an electron from the metal is called the work function. So it's energy. Usually it's represented in electron volts, sometimes in joules, not most of the time, but it's usually represented in electron volts. That's really all that is. And there's a couple of questions on the worksheet that just use that formula. They'll just tell you, if I remember the worksheet correctly here, let me just find it. Yeah, they'll just tell you, okay, what's the threshold frequency? They tell you the work function. The work function is that capital W, and then you can rearrange this to find the threshold frequency. Oh yeah, they use a little naught symbol there, so F naught is equal to the work function. Which is usually in electron volts, divided by the Planck's constant, right? You can also change this into like what is the max, or so what's the minimum wavelength, because this would be the maximum frequency. No, this would be the minimum frequency. What's the maximum wavelength that would cause a photo emission? Yeah, we're opposite, right? This would be the minimum frequency, that would be the maximum wavelength. So we could just also change this around and say, okay, rather than using an F here, I could also say W is equal to HC over lambda. You put a little naught there, it's like a threshold wavelength as well. Okay. Now to figure out if an electron is going to come out, you want to compare the two numbers, right? So usually you don't see this formula here, but you would want to compare to see whether or not the photon has enough energy, or compare the frequencies as well. Those are the easier ones to compare. So you can find the energy of a photon by using E is equal to HF. Okay, so there's the energy of a photon. And if the energy of the photon is greater than the work function, then there is a photo emission. Okay. Now, again, like I said before, it doesn't necessarily mean that photon is going to cause a photo emission. But if I shoot a bunch of photons there, one of those photons is going to hit one of those top level one electrons and pop them out. There's going to be a lot of photons coming into this metal. Some are going to go deeper into the metal and refract inside, but some are going to hit the electrons at the top and pop them out. So as long as that photon energy is greater than that work function, there should be a photo emission at some time, one point. One of those photons will pop an electron out. right? So you just have to make sure you pass that threshold frequency. You also think about this too. You could say the frequency of the photon, because they are directly proportional to each other, that energy and frequency. If the frequency of the photon is bigger than the threshold frequency, then yeah, there should be a photo emission as well. So something should happen. Okay. So that's all I wanted to talk about in this video. The next video we'll talk about how do we measure the kinetic energy of the electrons being emitted by this frequency, and something called the stopping voltage. You'll see that. I've already released next week's lesson on this topic, because obviously this was a short little lesson. And so you can continue on, talk about this. It just seems like a natural progression into our EMR particles. And then after this lesson, there's a video talking about, or a lab with stopping voltages. And we're going to calculate some threshold frequencies and work functions of an unknown metal, or actually we know what it is, so we can compare it to the known value. And I'll see you in the next video. Bye.